I would like to make a brief comment about the Research Domain Criteria project of the NIMH, the RDoC project. This is a very important project trying to relate brain disturbances to mental disorders, and it is really very important in order to offer a future brain-related diagnostic system. I'm afraid that this project stands the risk of a localistic effect, in the sense that, like in the past, we used to think that mental functions are localized in the brain, and today we know that the brain is an integrative, complex system where mental functions result from integrative cortical processes which are not specifically localized. In order to avoid this kind of risk, we need to introduce conceptualizations from neural network dynamics and from computational neuroscience. And if we want to look at specific systems, we have to take this into account. For example, let's take the example of schizophrenia spectrum disorders and psychosis. We know that the frontal and prefrontal cortex has been repeatedly found to be relevant to these disorders. And if we look at these systems, we know that the prefrontal cortex has a massive integrative input-output relationship with the entire cortex, and it probably acts as a communicating, connectivity, balancing system. We know that the prefrontal cortex receives dopaminergic innervation from the dopaminergic system, and that this system has both excitatory and inhibitory effects on these pyramidal prefrontal cortical neurons, excitatory directly and inhibitory indirectly through the interneurons. Such an activity of both excitatory and inhibitory seems to be a modulatory activity, where probably it can control the input-output relationships of these pyramidal neurons. Now, assuming that these neurons receive massive connectivity from the cortex and outputs massive connectivity to the cortex, then these neurons stand the position of being connecting relay neurons. And if we increase their threshold by disrupting, for example, input-output relationships of these neurons, then we can get an effect of a disconnection dynamics for the brain, and vice versa. If these neurons have an increased input-output relationship, thus immediately outputting the massive input that they receive, then there is an overconnectivity relay dynamics for the brain. So in this way, we can start and conceptualize how a specific system and its dynamics may be relevant to mental disorders, to schizophrenia, for example. There are repeated publications that show that disconnection dynamics may characterize psychosis, and that overconnectivity dynamics may characterize the deficiency syndromes of schizophrenia. So here we have this link between the dynamics of the brain, a specific system, and a specific set of clinical manifestations. So I think this can exemplify the importance of introducing the neural computation dynamics in between the clinical phenomena and the brain relevant systems. You can read more about it in a more detailed and extended form in recently published papers, one titled Neuroscientific Psychiatric Diagnosis, and the other one, the Neurophysics of Mental Disorders. There is also a book titled Neuroanalysis, which really details everything in a very extensive manner.